Picture this: a room full of engineers in Pasadena, California, coffee cups everywhere, tension so thick you could cut it with a knife. They have been staring at the same screen for 5 months straight, and all it is showing them is nothing. The spacecraft they are trying to reach is over 14 billion miles away. It launched before the personal computer existed, before the internet, before most of the people in that room were even born, and for 5 whole months, it went completely silent. No science data, no telemetry, no position updates, just pure, eerie silence from the very edge of the known universe. This is the story of Voyager 1 and Voyager 2, what they discovered at the outer boundary of our solar system, why those discoveries stunned the entire scientific world, and how one desperate repair attempt brought a dying spacecraft back from the brink. Let's get into space. In 1977, NASA engineers noticed something remarkable on their orbital charts. Once every 175 years, the 4 outer planets of our solar system line up in a way that makes a single spacecraft tour of all of them physically possible. The gravity of each planet can slingshot a probe toward the next, like a perfectly timed relay race across the cosmos. That window was opening, and it would not open again until the year 2153. NASA was not going to miss it. On August 20th, 1977, Voyager 2 launched from Cape Canaveral, Florida. 16 days later, its twin, Voyager 1, followed. Despite launching second, Voyager 1 took a faster trajectory and quickly overtook its sibling in the race outward. The original mission plan was surprisingly modest. 4 years, study Jupiter and Saturn, take photographs, transmit data, done. But NASA's engineers had quietly designed the flight paths with a hidden ambition. If everything worked perfectly, the probes could keep going, past Saturn, past Uranus, past Neptune, and eventually beyond the solar system itself. Everything worked perfectly. By 1979, both Voyagers had reached Jupiter, and they immediately started shattering assumptions. Before these missions, Jupiter was little more than a blurry disk in even the best telescopes on Earth. After Voyager, it became a world. Scientists saw the Great Red Spot up close for the very first time. This is a storm so enormous it could swallow 3 Earths placed side by side, and it has been spinning continuously for centuries. No one had ever seen it in detail before. Up close it looked violent, beautiful, and deeply unsettling all at once. The probes also discovered that Jupiter has rings, thin and faint, but real. Nobody expected that. And then there was Io, one of Jupiter's moons. When the images came back, a scientist named Linda Morabito spotted something on the surface that nobody was prepared for. A volcano, actually erupting. Right now, in real time. It was the first active volcano ever detected anywhere in the solar system beyond Earth, and it was happening on a moon that astronomers had largely ignored. Then there was Europa. Its surface was covered in smooth, cracked ice. Ice that looked exactly like a frozen ocean broken apart by movement underneath. That single image sparked a hypothesis that has driven billions of dollars in research ever since. A liquid ocean, possibly capable of supporting life, hiding beneath that frozen shell. From Jupiter, both probes used the planet's gravity to slingshot themselves towards Saturn, arriving in 1980 and 1981. What looked like a few simple rings through ground-based telescopes turned out to be hundreds of them, an intricate layered system of ice and rock constantly interacting with Saturn's moons, constantly shifting. It was nothing like what anyone had imagined. One of Saturn's moons, Mimas, had been struck by an ancient asteroid so powerful that the resulting crater gave it an almost perfect resemblance to the Death Star from Star Wars. Scientists did not name it that officially, but try telling that to the internet. Then came Titan, Saturn's largest moon and one of the most haunting places in the solar system. Its atmosphere was so thick and hazy that Voyager's cameras could not see through it at all. The surface was completely hidden, but the temperature readings told a strange story. Conditions on Titan were close to what scientists call the triple point for methane, meaning methane there could exist as a liquid, a solid, and a gas simultaneously, just like water does on Earth. Methane rain falling into methane rivers, flowing into methane seas. Titan forced scientists to completely rethink what a potentially habitable world could even look like. After Saturn, the two probes went their separate ways, permanently. Voyager 1 had been steered toward Titan for a close study of its atmosphere. That choice came with a permanent cost. The flyby angle flung it out of the flat plane of the solar system, away from the remaining planets. There was no coming back, no second chance. Voyager 2 got to keep going. In January of 1986, it became the first, and to this day, still the only, spacecraft to ever fly past Uranus. And what it found there rewrote the textbooks. Unlike Jupiter and Saturn, which are made mostly of gas, Uranus has a thick internal layer of water, ammonia, and methane ice surrounding a rocky core. Scientists created an entirely new planetary category just to describe it, the ice giant. And that axial tilt, Uranus spins almost completely on its side, like a ball rolling along the floor rather than a top spinning upright. Voyager 2's flyby showed us what that bizarre orientation actually looks like from up close. Strange and beautiful and unlike anything else in the solar system. In August 1989, Voyager 2 completed what NASA called the Grand Tour, the first and only time in human history a spacecraft visited all 4 outer planets. Neptune appeared deep blue, with enormous storm systems swirling across it. One storm system, the Great Dark Spot, was roughly the size of Earth itself. It appeared without warning and later disappeared just as mysteriously, and the winds on Neptune, the fastest recorded anywhere in the solar system, gusts exceeding 1,200 miles per hour, on a planet so far from the Sun that sunlight there is 900 times weaker than it is on Earth. Where Neptune gets the energy to drive those storms is a question scientists are still arguing about today. That flyby was the last planetary encounter either Voyager would ever make, but the most significant discoveries were still ahead. On February 14, 1990, scientists made one final request of Voyager 1 before shutting down its cameras for good. They asked it to turn around. From a distance of nearly 4 billion miles, Voyager 1 looked back at the solar system and photographed it. 60 individual frames, one wide mosaic image, and somewhere in that image, barely visible even when you know exactly where to look, was a tiny pale speck of blue and white light. Earth. Not even a full pixel in size, suspended in a band of scattered sunlight, a mote of dust floating in a sunbeam. That photograph became one of the most iconic images in human history. The astronomer Carl Sagan, who had pushed for years to get this picture taken, described it in a reflection that is still quoted today. Then the cameras went dark, and the real science, the kind no one had planned for, was just beginning. For decades, both Voyagers travelled through a region scientists had theorised about but never actually measured, the outermost layers of our solar system. The Sun does not just emit light and heat, it constantly blows a stream of charged particles outward in every direction, called the solar wind. This stream creates a giant invisible protective bubble around our entire solar system, a bubble called the heliosphere. Every planet, every moon, every asteroid we have ever visited exists inside it. Scientists had long assumed the solar wind simply fades gradually the farther it travels from the Sun. Like warmth from a fire, slowly weakening with distance until it blends seamlessly into the surrounding space. The Voyagers proved that assumption completely wrong. In August 2012, Voyager 1's instruments registered something sharp and sudden. Solar wind particles dropped almost to zero. At the same moment, galactic cosmic rays, radiation originating from beyond our solar system entirely, flooded the sensors. Voyager 1 had crossed the heliopause, the actual outer edge of the Sun's influence. And it was a hard wall, not a gradual fade. It was the first human-made object in history to enter interstellar space. What it found on the other side contradicted decades of theoretical models. The interstellar magnetic field was 2 to 3 times more powerful than predicted. The plasma was colder and denser than expected, and the pressure that interstellar particles exert on the heliosphere was 10 times greater than scientists had calculated. Voyager 2 crossed the same boundary 6 years later in November 2018. Having 2 crossing points allowed scientists to compare data from different locations, and what they found made the picture even stranger. The heliopause is not a smooth, stable shell. It moves, it ripples. Giant waves, each spanning close to 1 billion miles, roll across its surface at irregular angles and unpredictable intervals. The outer edge of our solar system is constantly churning, and the reason those two crossing points happened 6 years apart, rather than simultaneously, is still not fully explained by any model we currently have. And this brings us back to that control room, November 14th, 2023. Without any warning, Voyager 1 stopped making sense. Instead of transmitting real science data, it began sending back a repeating loop of garbled numbers. Not static, not silence, just the same meaningless patterns cycling over and over. The spacecraft was clearly still powered, still transmitting. It was trying to communicate, but nothing it sent could be understood. The problem, after months of painstaking investigation, turned out to be a single corrupted chip inside the flight data system, the part of the onboard computer responsible for organizing and packaging all data before transmission. A tiny hardware failure on a spacecraft launched 46 years earlier, 14 billion miles away, unreachable by any physical means. Here is what made this genuinely terrifying for the engineers. Any command they sent took 22.5 hours to reach Voyager 1. Then they had to wait another 22.5 hours for a response. Every single attempt at a fix was a 45-hour round trip, with no way to know if it worked until nearly 2 days later. The team eventually developed a plan. Since the damaged chip could not be repaired remotely, they would redistribute the corrupted code, split it up and move the pieces into other sections of Voyager's memory that were still functioning, essentially patching the software around a broken piece of hardware. On April 18, 2024, they sent the command. Then they waited. 22.5 hours passed, then another 22.5. On April 20th, 2024, after 5 months of silence, Voyager 1 responded with clean, readable, usable data. The mission was alive. Today, Voyager 1 is over 15 billion miles from Earth, moving away from us at roughly 3.5 times the Earth-Sun distance every single year. Its radio transmitter uses about as much power as a refrigerator light bulb. By the time that signal crosses the full distance to Earth, it carries less energy than 1/10,000 trillionth of a watt. NASA has to point 3 of the largest antenna dishes on the planet simultaneously just to hear it. Scientists expect the power systems to go offline sometime between 2025 and 2030. One by one, the instruments will shut down, then the transmitters, the permanent kind of silence. After that, the probes do not stop. They just stop talking. Voyager 1 is headed toward a faint star in the constellation Ursa Minor. It will pass within 1.7 light years of it, roughly 40,000 years from now. Voyager 2 is aimed at a small red star called Ross 248 in the constellation Andromeda, also tens of thousands of years out. On both probes, bolted to the outside of the spacecraft, is a golden record, a 12-inch gold-plated copper disc. It contains 115 photographs of Earth and its people, greetings in 55 languages, 90 minutes of music from cultures across the world, and the sounds of our planet, rain falling, wind blowing, ocean waves. It was made for anyone, or anything, that might ever find it. We have no idea if that will ever happen, but we sent it anyway. Because that is what exploration actually looks like. Not certainty, not guarantees, just the willingness to send something into the void and say, we were here, we existed, we were curious, and we looked up. If you want to follow along as these missions continue, and there will be more surprises before the signal finally goes dark, subscribe to get into space and hit the notification bell. We will be here for every update. Thanks for watching.